video on polynomial regression. So the first thing you do is you plug a regression equation into stat edit. So you hit stat enter, and then you would plug a regression equation in to your calculator. Okay, so I have an regression equation here on the right here that I'm going to use. So it'd be 10. Well, I'll pause it as I plug that in. Okay, now that I have that plugged into my calculator, as you see here on the left, the T is my L1 or my independent, and my L2 is my H of T or my dependent. Once I have that plugged in, then I have to set my calculator up so that I can find a regression equation that's the best fit for the data. So in order to do that, on a new calculator, 84 with an updated operating system, you simply go to Mode, then you hit the up arrow, and then it's going, you see here where it says Stat Diagnostics, you want to go ahead and arrow over to the right and hit enter to turn it on. So that's the way you do it on a TI-84 with an updated operating system. Now, if you did not have a TI-84 and you had a TI-83, what you would do is you would hit second 0 to go to the catalog, and then you would do alpha, and then you would do the letter D. Alpha D. And that's it's alpha, and then it's the little x to the -1 symbol here. And then you would go down to diagnostic on, and your cursor would be next to it, and then you would hit enter twice, and then it would say done and your diagnostics on. What that does is when you hit stat, okay, and you want to calculate the regression. So notice here in the problem it says what type of regression best fits the data: linear, quadratic, cubic, quartic, logarithmic, exponential, or power. If you go stat and then over to calculate, you'll notice here option 4 is linear, option 5 is quadratic, option 6 is cubic, option 7 is quartic, option A is the power regression, exponential is option 0, and the logarithmic one is option 9. So what you simply do is you would select one of those. So I'll start with the linear guy first. Okay, and what the stat diagnostic does is it tells me the likelihood of that the table being represented by a linear function. So what I do is hit stat calc, choose number 4 for linear regression. If you have the newer operating system, you get this option here. Otherwise you'd get it would just simply say line reg. This part would just simply show, and you would hit enter. So I hover over calculator, hit enter, and what I'm looking for is the r² value. Now the r² value must be 1 or closest to 1 as possible. That would tell me the one that best fit the data. So if this r² value is 0.922, so here we can, just so we can keep track here, we'll say that our linear guy was 0.922. So now we want to go ahead and check the quadratic guy. So we do the same process, stat calc, and then we choose number 5 for quadratic, and we go down to calculate, we hit enter. We see that quadratic has a r² value of 0.99239. So you notice that the quadratic guy is closer than the linear guy. So we see that this guy definitely is not linear. We do the same thing, stat calc, choose number 6 for cubic, go down to calculate, hit enter. Okay, so for the cubic guy, we see I have a r² value of 1. I have an r² value of 1. So because r squared is equal to 1, we know that it's a cubic equation. So where it says what type of regression best fits the data, we would write cubic, and then you must justify your answer. It's because r squared is equal to 1. Then it says write the particular equation. So the equation, the a, b, c, and d represents the coefficients of the terms, the x variables from highest degree, from the highest exponent in descending order. So it'd be y equals 0.1 x to the third minus 10.3 x squared plus 370x minus 1020 minus 1020. So that would be my equation. Now it says how high is the rocket after 47 seconds? So we know that in this problem my t is seconds. So what I can do is when I do stat calc, I know it's cubic 6. It gives me the option here for store regression equation. So what I could do here then is I hit vars, I arrow over to y vars, I choose function, option 1, and then I choose where I want it stored, y1, y2, y3. Normally we just choose y1, so I store it in y1. And then go down to calculate. When I hit enter now, it's going to store my equation into y1. Okay, now they asked me a question, how high is the rocket after 47 seconds? So what I can do here is I go to my window, and I know that my x value needs to be bigger than 47 seconds. So I can say 60 seconds. So my x max is 60 seconds. My y max, I look at my table, my biggest y value is 5700. So I will make my y max say 8000. Doesn't matter what the y min is. We know that if it's a rocket, it has to hit the ground. That's when the y min is 0. So we won't have to worry about that. Let me hit graph, just so I can get a pictorial representation of the graph. Okay. Okay, now, so then I simply hit trace and I type in the value that they want and I hit enter. So at how high is the rocket at 47 seconds? Well, it's at 3,999.60 feet. Okay, and then the next question says how long will it take the rocket to reach 75,000 feet? That's the y value, or h of t. So I would go to y equals, and then y2 I would put in 75,000, and I'm looking for where it intersects the graph. Put in 75,000, I hit graph. Okay, and now I notice I made my y max 8,000, so I know I'm going to have to go in and change my window to a number bigger than 75,000. So I'll make my y max 80,000 and hit graph. Okay. And notice there, I see that the graph 75,000 is up here, but I see I still have way more ways to go. So go here and I make my x max say 1,000. All we're trying to do is to see where the graph crosses. We see that 1,000 is too much, but it allows me to see the upward curve of the graph to see where they actually intersect. So that's good there. Then I just simply do second trace, number 5 for intersection, and then I hit enter 3 times. And then my calculator is going to tell me when or what time it takes, or at what time the rocket's at 75,000 feet. So my answer would be 123.106 seconds. Depending on when we ask you, we may ask you to do to 2 decimal places, which is the hundredths place, the tenths place, which is 1 decimal place, or the thousandths place. So in this case, we just rounded to the thousandths place. And that, in a nutshell, is how to find a regression equation. As long as they give you the table you're looking for, which function gives you an r squared value closest to 1, and that's the one you would use for your regression equation. Okay, scratch my thought about the graph, the rocket hitting the ground. That has nothing to do with the problem in this instance. The rocket is going up in an upward upward altitude, it will continue to go up, eventually level off. But in the essence of the problem, we're just giving you an example of a table and a situation so that we can find the regression equation.